Assalamualaikum and good day everyone. Today we will continue our chapter 5, which is a 5.4 spanning tree. At the end of the class, you should be able to find spanning tree of a simple graph. A spanning tree of G is a subgraph of G that is a tree containing every vertex of G. Let G be a simple graph. A simple graph is connected if and only if it has a spanning tree. So the spanning tree is the tree plus containing all the vertices of G. We know that a tree is a undirected graph. A tree is a connected undirected graph with no single circle. So the theorem for a tree is a tree with n vertices has n minus 1 edges. So for the spanning tree is the tree plus containing all the vertices of a simple graph G. Alright, this spanning tree is applied in the IP multitasking. So let's see the example of the spanning tree. We have the given question here, a simple graph G at the figure 5.4.1. We can see here that a simple graph G have 7 vertices and 9 edges. So for the spanning tree, to find the spanning tree of the simple graph G at the figure 5.4.1, we need to include all the 7 vertices that have in the simple graph G, and we need to find the minimum edges that connecting all the 7 vertices. Alright, let's see for the first spanning tree. So we have the subgraph of G here. We see that all the vertices, all the 7 vertices here is connecting with n edges. So we have the A connecting with B, B connecting with F, F connecting with E, and F connecting with G, G also connecting with the C, and C connecting with the D. So we have 7 vertices here, and it's connecting with the 6 edges. So the 6 edges is the minimum edges that can connecting the 7 vertices. So we know that a spanning tree is a subgraph of G that is a tree containing every vertex of G. So for this subgraph, we see that it contains all the 7 vertices, and also it has the 6 edges here. So it's follow the theorem of the tree that n vertices has n minus 1 edges. So this subgraph is the spanning tree. Okay, so let's see for another example here. We see here it's contain all every vertex of the simple graph G. We have the 7 vertices here, and it's connecting with the 6 edges here. So this subgraph also the spanning tree. Okay, let's move to another example. We have here the figure 5.4.2. So we see it contain all the 7 vertices that have in the simple graph G. So this is the subgraph of the simple graph G at the figure 5.4.1. So we see that it contains the 7 edges and the 7 vertices. So this is not follow the theorem of a tree. So this is not a simple tree. Alright. So how we want to transform the figure 5.4.2 into the spanning tree? So we just remove the edge EG here, so it can become the spanning tree since it contains all the 7 vertices and it has the 6 edges that connecting with the 7 vertices. Alright. Okay. So this is the exercise on the spanning tree for you to test your limit of understanding. So that's all for the spanning tree. Thank you.